And then we started to solve some.
Hello, teacher.
Hello, Salman.
How are you?
I'm fine, thank
Hello,
you. How are you?
teacher.
Hello. So we gave some special right triangles. One of them was isosceles right triangle. In isosceles right triangle, what we had as property? Both
Both are sides.
both the sides are the same, and we gave some hints directly how we can find the sides in isosceles right triangle. And then we had another one, 30, 60, 90 right triangle. And also in that one, we gave some properties how we can find the sides of that kind of right triangles. Now here in the second exercise here that is written to find x and y in each figure, you have that special right triangles. So I am giving you time while I'm taking the attendance to start to solve them, okay? And then we will solve together, okay?
Okay, teacher, and which page are they?
In the book, I don't know which page they are. Let me check. It is on page 75.
Okay.
Page 75, practice problems, the second one. Check if you can solve them.
Hello, teacher.
Hello, Stanislav, how are you?
I'm fine, teacher.
Now Yusuf is here. Yusuf?
Yes, teacher, I'm here.
Okay. Anita?
I am here, teacher.
Okay. Alexander?
I'm here.
Okay. Eva?
Here, teacher.
Elza?
Here, teacher.
Amra? Amra? Yona?
Here.
Here. Stephanie?
Here.
Here. Fatih?
Here, teacher.
Here. Kibariye?
Here.
Here. Tringa?
Teacher.
Here. Ardita?
I am here, teacher.
Arta?
I'm here.
Here. Giovanna?
I'm here.
Vesa?
I'm here, teacher.
Okay. Stanislav?
I'm here, teacher.
Salman?
I'm here.
Okay. Rumeysa?
I'm here.
Sara? Okay. Ermal? Ermal? Guys, can you hear me? Guys, can you hear me?
Yes, teacher, we can hear you.
Yes, teacher.
Something happened and it started again. Okay, I was calling Ermal.
I'm here, teacher.
Okay. Hamza? No. Besan? Besan? No. Guys?
Here, teacher.
Yusuf, close the meeting.
Guys, I'm back.
Teacher, your internet connection isn't okay.
Yes, it kicks me out from Zoom and connects again. I don't know what's the problem. And I think Besan was here at the end. I was calling him. Sorry. Now, did you solve?
Yes,
Can you see the screen now?
yes.
Okay.
Yes.
So first one, A will solve, let me choose one of you, someone who is not talking. For example, Ermal. If we have, Ermal, are you here? Ermal is not answering.
Teacher, I'm here, but I don't understand. So I would like.
So
to
Ermal, if you have
someone else.
an isosceles triangle, what does it mean, an isosceles triangle, Ermal? We know what does mean isosceles triangle. Ermal
That's hard to see.
or Ezan?
Sides equal length, teacher.
I cannot hear you.
The two sides.
Two sides?
Two sides are the same length. Teacher.
Two sides has the same length. So here, from where we can say that this triangle is an isosceles triangle? We have 90 degrees given, 45 degrees given. So here, because this is when I will add 90 plus 45 will be 135, yes?
Yeah.
So 180 minus 135 will give me 45. So if two angles are same, it means that this triangle is an isosceles triangle. So as you said, Ermal, if we have isosceles triangle, two sides are the same. Which ones will be the same then here? For example, 6 and y will be the same, or 6
6 and x, teacher.
will be the same.
6 and x.
So directly we can find that x is equal to 6, yes?
6, yeah.
Now, how I can find the y? This is a right triangle. Y square will be equal to,
Can you continue it a little bit more, teacher?
I
Y
cannot
squared.
hear you well, Erman.
Can I solve, teacher?
My internet connection is very bad, teacher. That's why.
Okay, Alexander wants to help you. Yes, Alexander,
Y square is equal to x square
x square
plus 6 square.
plus 6 square.
It will be y square is equal to 36 plus 36 because
So
x
x
is
is, yes. So 6
Yeah, x is, yeah.
plus 6 square, it will be
Plus 6 square.
36 plus 36. Then,
y square is
Yes.
equal to
72.
72
72. Then y is equal to,
root of 72.
you can left it like this, or you can write that y is equal to 2 times 36, which will be 6 root of 2. And from the properties of an isosceles right triangle, if we know one of the legs, directly we can write that y is equal to 6 root of 2, if you will remember. You don't have to do all these operations, okay? Now for B, Stephanie,
My teacher.
one said, can I? I didn't understand who is.
I said, can I? Johan.
Giovanna. Let me hear Stephanie.
Okay.
Then
Teacher,
if she doesn't want or she cannot, we can solve with you, Giovanna. Can you hear me properly, by the way?
Yes,
Yeah.
teacher.
Okay. Now, Stephanie,
yes, teacher.
here we have the special triangle 90, 30, and what will be the other angle here?
It will be 60.
60.
Stephanie is answering.
It will be 60, teacher.
It will be 60. And in this kind of triangle, what we said, do you remember? If we have 30, 60, the hypotenuse, if it is 2a, the side opposite of 30 will be half of it, a. And the side opposite of 60 will be a root of 3. According to this one, you need to remember this small triangle always. Still, I am drawing this one when I have a question like this to solve. I'm drawing it on a side and writing directly 2a, a root of 3. And according to that, I'm solving my question. Now here, Stephanie, which side is given? The side opposite of 30. Yes? The side opposite of 30 is given. A is given. It's 7. So according to this one, what will be y?
I think it will be 2 times 7.
2 times 7, which will be 14. So directly we have found y. What about x? X is the side opposite of 60. Then look, it is a root of 3. So what is our a here?
Root of 3.
One more time, I couldn't hear you.
7 root of 3.
7 root of 3 will be directly. You don't have to do anything else here. It's okay, the others?
Okay.
Yes, teacher.
Yes? Did you understand the logic of this 30, 60, 90?
Teacher, I don't understand the logic of y is equal to 2 times 7.
A previous lesson, I showed you how we found it. If it is here still. Yeah, here, as you can see. We found here when we have 30, 60, and 90 degrees that hypotenuse is 2x, the side opposite of 30 is x, and the side opposite of 60 is x root of 3. We found here with the Pythagorean theorem. So
Okay.
we know this, we found it. You don't have to use the Pythagorean theorem again and again. Directly you can write this. But if it is not understandable, you can use the Pythagorean theorem. But again, you need to remember some of the properties, because if you don't remember that y is 2 times 7, you cannot use Pythagorean theorem because two sides are unknown. Did you understand now?
Yes. So teacher, only if it's 30 and 60 degrees?
Yes, only in 30 and 60 this one works.
Okay.
And we have C, one more. Here, it's 60, 30 given x,
And 9.
y, and 8 root of 3. Now here, according to our small triangle here, which side is given?
A root of
A root of 3.
Opposite of 60. A root of 3 is given as
X.
8
X.
root of 3. So our A is equal to 8. A is opposite of 30, so it means that X is
X is
equal to 8. Yes, am I right?
yes.
Yes, yes, yes,
So
yes.
what will be Y?
2 times 8.
2 times 8, which is 16.
Which is 16. Okay. So we understood this one?
Yes.
Teacher, I found it 2 root of 2 times root of 2. 2 root of 2.
2 root of 2. Where you found 2 root of 2?
I don't know.
In this question, I mean.
Yes, in C.
How you found 2 root of 2?
Teacher, I got y as I did y. That x is 2 times y.
Mhm.
No. Y is 2 times x, and I did like 2 times x root is
You
equal
have-
to x root plus 8 root of 3 root.
So you mixed something there and
Yes.
yes. Now in the third one, in the third example, what we'll do, how we'll do. Look, you have here, you can, in A, it's easy to find x because we have here 10, 6, and with the Pythagorean theorem, you will find x, yes? And when you will find x with another Pythagorean theorem, you will find the y. We have 2 right triangles here. Am I right? Did you see it?
Wait,
Yeah.
what did you say, teacher?
In the third
There-
example, A, how we'll find x and y? Here, the angles are not given. Don't
After
think
that
we
one.
can use these properties. But we can use the Pythagorean theorem, yes? Two sides
Yes.
are
X plus 15 is equal to y.
x plus 15.
X squared is equal to 10 squared.
Yes, x squared
yeah,
plus
yeah,
15
yeah,
squared is
yeah.
equal to y.
So I am not solving this, it's yours, you can do it. What about in B? Look, we have again 2 right triangles, a big one and a smaller one. In the big one, we have hypotenuse given and one of the leg is given. Can we find the other one?
Yes.
So let's
Yes.
do it together for the ones maybe who is not that. Now here in B, we have this one. So y 10, 3 root 2, 2 root 2 x. Tringa, are you here?
Yes, teacher, I'm here.
Okay, so let's solve it together. I'm drawing one more time. Only the big triangle,
Okay.
if I can draw. So we have here 10, here x. What will be this side? 3 root 2 plus 2 root 2. Yes, am I right?
Yeah, I think yes.
Yes, so 3 root 2 plus 2 root 2 will be, this is not
Five.
geometry,
5
5 root
Five.
2.
root 2.
root 2. So this one is 5 root 2. Now, this is, we know that it is a right triangle, it's given. In this right triangle, how I can find x, Tringa? Tringa?
Yes, teacher, I'm here, teacher.
I cannot hear you. We have Pythagorean theorem. We know Pythagorean theorem.
Yes.
Yes, what is Pythagorean theorem? Heidi Tringa? So you haven't watched the movies, I would say. The videos, the lessons, or did you didn't listen, or you didn't understand?
I'm listening, but you know, when I get something that I don't understand it in my head, when I put that, and I'm like lost.
But this one is from primary school, Pythagorean theorem. We have a right triangle. We know what is right triangle. We know what is hypotenuse, yes?
Yes.
So in Pythagorean theorem says that the square of hypotenuse, which one is hypotenuse? 10.
10, okay.
10 square is equal to the sum of the squares of the other sides. So what I have that in the other sides? 5 root of 2 square plus
X square. Okay.
x square. So what is 10 square?
100.
100. Here how I will take this square? 5 square, which will be 25 times root 2 square. The square root and square will cancel each other, yes?
Yes.
And plus x squared. So what I have here, 50. 100 is equal to 50 plus x squared. And then x squared will be
100 minus 50.
50, which is 50.
50.
So x will be root of
50.
50. You can leave it like this, or you can write that this one is 2 times 25. So x will be root of 25 is 5. Root 2 will stay inside of the radical side. So I found that x is equal to 5 root 2 from the big triangle. It's okay.
Teacher, we could also go like 45 degrees, and
but the angles are is not given. If it was given that this is 45, and directly we'll say that this is 45, and directly we'll say that this is 5 root 2, but it's not given. So we need
okay, because there are 2 triangles in one.
Yeah. Now I'm taking the small triangle. Oops, I couldn't draw it. Okay. You can understand that this is a right triangle. So this is y. This is 2 root 2, and we found that this one is 5 root 2. Yes, Tringa, now, again, with the Pythagorean theorem, what will be here in this right triangle?
So y squared
Yes.
equals 2 the root of 2 square
Okay.
plus 5 the root of 2 square.
Yes. Then what will be 2 root 2 square?
So 4 times 2.
4 times 2 plus
25 times 2.
25 times 2.
Which is 8 plus
Yeah.
50.
50.
58.
58.
So then it will be the square root of 58.
The square root of 58. So you can leave it like this, okay? If you can do a simplification like this, if you can find here inside of 58, then you can find the square root of it, you can do, or you can leave it like this, okay?
I got it now.
Okay, please, guys, look, I am skipping the topics. I am solving the questions. Some of you understand and talks, and we are solving with them all the time together. But if you don't say anything, if you don't ask anything, I cannot feel that you don't understand. Okay?
Teacher, the C1 will be the same with Pythagoras, right?
Yes, the C1 will be the same. Here it's given that what is given is that this side is parallel to this one. The opposite sides are parallel. So it means, and all the angles, if it's 90 degrees, it means that this is a rectangle. So if
the sides are given directly.
7, and this one will be 7, and
24.
and the other one will be 24. So directly you have found x. This is 7. This is 24. And then y you will find with the Pythagorean theorem. It's okay, guys.
Yes.
With the Pythagorean theorem and with the special triangles, 60, 30, 90, and we had 45, 45, 90.
It's okay, teacher.
These ones are important. Why they are important? Next year, when you will start with a trigonometry, you will need this, okay? The right triangle, the properties of the right triangles, because the trigonometry works all, the base of the trigonometry starts with the right triangles. So if you don't understand, if you don't get now here, then it will be problem in the next steps, okay? So this is, look, I started the lesson as the easiest part of the triangles. But if there is a problem, please ask me, tell me. If you don't tell me like this, because also I cannot see you what you are doing. And if you're not talking, I cannot feel the problem. Where is the problem? Okay?
Okay.
Repeating all the time the same things, but guys, if you don't talk, I cannot do anything by my feelings, you know? Oh yeah, I am feeling that Eva doesn't understand. I cannot do this, unfortunately. So please tell me if you don't understand. Now, I am giving another theorem, important theorem about right triangles. It's called the Euclidean theorem. Here it's written two theorems. We have first Euclidean theorem and second Euclidean theorem. It's very hard to pronounce the Euclidean part. Now here, if you can see the given figure, we have here a big right triangle ABC, and we have another here AKC, if you can see. So it is drawn here from the vertex A, it is drawn another height, okay, H. So according to the first Euclidean theorem, it says in any right triangle, the square of the length of the altitude, this is altitude, okay, height, altitude to the hypotenuse, is the product of the lengths of the segments it forms on the hypotenuse. So what it says, this h square is equal to p times q. As you can see here, we have p and q. So the altitude that is drawn to the hypotenuse, this is the hypotenuse, is h. So h square is equal to p times q. Did we understand?
Yes, yes.
You need to understand from the figure, not these, you know, words here. It may seem like what is saying, but from the figure, you have a right triangle, and from the right angle, it is drawn another height to the hypotenuse. So that height, the square of that height, is equal to the product of the parts in the hypotenuse that is formed by the height. Okay?
Okay.
Second Euclidean theorem says that in any right triangle with an altitude h to the hypotenuse, the same one, the square of each leg is the product of the hypotenuse and the length of the adjacent segment of the hypotenuse intersected by h. What does it mean? I will show you here in the figure. So as you can see, c square, I'm taking one of the legs, c square is equal to p times a, all the side like this, p times a, if you're taking the c square. If I'm taking the b square, it will be q times a, all the side. Did you understand?
Yes, yes, yes.
C, p times a, b, I mean c square, p times a, b square, q times a. Are we clear with this?
Yes.
You can write this one, you can draw this triangle and write only these parts, not all the explanation. Only, for example, for the first Euclidean theorem, h square is equal to p times q, and for the second Euclidean theorem, c square is equal to P times A, B square is equal to Q times A. Okay. And I think that we don't have too much time. While
We
you're,
have another lesson.
we'll finish this, and then, as you said, next lesson, we'll see each other.
See you. Goodbye.